Hello, my name is Sabrina Zapata. This video will discuss my experience in the CIMA-LSAMP program for the summer of 2019 and also leading up to the program. My interest in the CIMA program began in my first semester of college since I saw a flyer near my biology classroom. I did not decide to pursue the opportunity until my sophomore year of college. I submitted my application and in March of 2019 I received an email of acceptance. I was so excited and eager to begin, but I would have to wait until late May to start. Before the program began, I met with both principal investigators of my study. They told me about their research, such as the impacts of invasive plants, how microbial genomics has advanced, and the significance of their research. The significance of their research can be seen through the mission reach of the San Antonio River Improvements Project. From looking at their website, if invasive plants took over the riverbanks, it would probably affect the surrounding wildlife. As I have learned from the study I participated in, native plants can actually struggle to develop in competition with an invasive plant. Once invasive plants take over, native animals that depended on those native plants will likely be driven away. They would have to find their native plants somewhere else. Native plants also aid in improving water quality by filtering runoff water before it gets in the river. This case indicates this study's significance. Herbicides cannot be used because they would contaminate the river water. So what if we fought a plant against another plant? The Friday before the program began, I attended the CIMA orientation. During the orientation, I learned a lot about the general idea of the program, some helpful tips, the significance, and what the program has done for previous participants. The general idea I took away is that challenges can arise, and it may not be as smooth as someone imagined, but the participant can learn a lot and have an unforgettable experience. I personally strongly agree with this. Originally, my project was supposed to be on the results obtained from an equipment called the biolog, but later on we discovered a component called ecoplates that were necessary for the biolog were backlogged. That meant I wouldn't obtain my results in time for the symposium. When my PIs discovered this, they decided to switch me into the project I actually made my poster about. My poster is about the early development of Cytotes grama seedlings when affected by plant competition and microbes. The lesson I learned from this change and also many other experiences during the summer is that it's always good to improvise at times. It's okay not to follow a plan or, try to stick to something you have in your head. The Monday following the CIMA orientation marked the first week of the program. Since my main principal investigator was busy with a semester, I was given literature to read. It was mostly about microbial involvement and equipment for microbial genomics, which was the biolog I mentioned earlier. The next week, we had our first research meeting. Over the course of the program, these weekly research meetings set up the agenda for the week, covered our progress, and helped me understand what we were doing in the lab. This first meeting covered a lot. We discovered the projects for the summer, the plants we are using, treatments for the plants, interactions between the plants, and the preparations necessary for the projects. The plants of interest are Cytotes grama and Bermuda grass. Cytotes grama is a native species, while Bermuda grass is the invasive species. I know, you're probably looking at that board just like, oh my gosh, what do any of those abbreviations mean? Well, I'll walk you through it. BC is a scientific abbreviation for Cytotes grama, and CD is for the scientific abbreviation of Bermuda grass. And we came up with a abbreviation for each of the treatments that we had in the cones. So for example, N was the native inoculum, I was the invasive inoculum, A stood for the ampicillin, and this was meant to cancel out any microbial involvement, and the F stands for fungin, which was meant to cancel out any fungus participation. So when you see BCIAF, that is Cytotes grama with an invasive inoculum, also with ampicillin and fungin. After the research meeting, we began our preparations for the cones. This included washing all the cones, which was 240 small cones and 80 large cones. We also autoclaved coconut fiber that would be stuffed into the cone opening to prevent the cone filling from flowing out. This day, I learned about autoclaving and what it does. The machine we use is automatic, so there was not much to manually do. My principal investigators told us the major guidelines to follow, such as always checking the pressure meter before opening the autoclave and checking the presets. Autoclaving is extremely useful, as I learned in microbial projects like this. It helps reduce any quote-unquote background noise so that the data collected is definitely from the component being inspected rather than something else involved. The next day was our first day in the field. We went to a field where Bermuda grass and side oats were growing naturally and extracted soil from these respective places. We also extracted from different types of soils that would be used for the biolog later on in the summer. After the field work, a lab member and I cleaned sand that would be used for the cone's filling. It took the whole afternoon. The next day, the sand was autoclaved. The next week, we stuffed the cones with the coconut fiber, created labels for the cones, created a labeling key for the cones, and sifted the soils throughout the week. Sifting the soil that we collected from the field was difficult since most of them were still moist from the rain that week, and they also had a lot of clay content. I got a really good arm workout that week. We also started UV sterilizing the sand, and this proved very helpful. As we learned from the biolog later on, it cut down a hardly undetectable autoclave sand to an even more undetectable state. So when we harvest the soils from the cones in mid-August, the sand will have no microbial involvement. During that week, I also had my first CIMA workshop. During this one, we covered using databases and reading articles. These workshops occurred weekly and covered great topics to help the participant. The topics range from interpreting literature, creating a poster, conferences, and abstracts. I loved all the workshops, and the poster workshop is actually where I was introduced to the new poster layout I used at the CIMA Symposium. I highly recommend checking out this video. I won't spoil much, but the logic behind this new layout is great. The video link will be in the description. The following week, we subsampled the main soils that would be used in the inoculum. We ended up mixing the native soils together to create a pool, and the same was done for the invasive soils. From the native and invasive pools, we created a filling for the cones by adding the sand and mixing them together. We took jars and filled them with 95% sand and 5% soil inoculum. We filled the cones with one of three fillings: sand only, side oats inoculum, which is a native one, and Bermuda inoculum, which is invasive soil. We knew which cones needed a specific filling thanks to the labeling we had done on the cones. After all the cones were filled, we planted the Bermuda stems gathered from the field earlier that week. A lab member precisely cut the grass to have roots and one stem. Once all the Bermuda were planted, we moved on to planting the side oat seeds and the necessary cones. After they were all seeded, we watered them to last a weekend. Now at the halfway point of 5 weeks, we were now able to start taking measurements every other day. Most of the side oats had germinated over the weekend, and we labeled our germination day as June 24th in our data later on. During the latter half of the week, we started creating our nutrient solution for the plants. It is an adjusted Hoagland solution, and that Friday was the first time we watered the plants with the solution. The following week was relatively slow compared to earlier weeks since we just needed to take measurements and water the plants. We also started the ampicillin and fungin treatments on the Tuesday of that week. As I said earlier, my project was switched from the biolog data to watching the plants' early germination and tracking their growth. The other two lab members started the biolog project, so I did not get to see them as much for this week and the next few weeks. During the 6th week, the principal investigator and I went out to the field again to conduct transects of the field where we gathered the soil from. I learned how to take photo points and characterize the field through this method. It was interesting to me and fun. The 7th week of the program was a much busier week than the last. The principal investigator and I were working together almost every day because we had collected all the data necessary and needed to conduct analysis now. The data analysis took 2 full days. I learned a lot of techniques in Excel thanks to my principal investigator. I also learned the reasoning behind things like variance analysis and standard error. The next 2 weeks was filled with me creating a poster, preparing to present the poster, and even making this video. I am proud of my poster, and I hope it caught many eyes at the symposium. Over the summer, I've learned a lot of techniques and skills that will help me in my future. I would love to become a research scientist in the biology field, so this program is a dream for me. I got to experience something that I don't hear much people talking about. It's definitely different from classroom experience, but they're both a gateway to learning. I hope I can tell many about my experience and even get them to apply and even accepted. The program can be tough at times, but I loved every minute I spent in it. I had great mentors in my PIs, Dr. Valdez and Dr. Rushing, and great lab mates in Carla and Marissa. Dr. Wilson of St. Philip's College also helped me keep going with guidance. Thank you so much to everyone I mentioned, Dr. Miranda and Dr. Mercedes, for their recommendation letters, and NSF and CIMA-LSAMP for this opportunity. If you are an Alma College student and in the STEM field, I highly recommend looking into a program like this. I feel the experiences I got from this are unique and will set me up in the future, especially for the career I want in research. Thank you so much for watching my video, and don't forget to check out the links I have in the description. Thank you.